Welcome to another explainer. Today, we're diving straight into Class 10 Geography, specifically the chapter on resources and development. We're going to unpack the actual foundation of our planet's wealth to get you fully prepped and confident for your board exams. We're taking a journey from the absolute broadest definitions of what makes something valuable all the way down to the literal dirt under our feet. Let's get into it. Here is our quick roadmap for today. We'll be defining our resources, classifying Earth's wealth, touching on sustainability and Agenda 21, digging into India's major soil types, and finally wrapping up with erosion and soil conservation. Okay, part 1. Defining our resources. What exactly is a resource anyway? We throw that word around all the time, right? But in geography, it's actually pretty specific. A resource isn't just random stuff lying around in nature, like a lump of coal. It's not a resource to a society that doesn't know how to burn it. It literally only becomes a resource when humans have the technology to extract it, the economic means to actually make it profitable, and the cultural acceptance to use it. So it's this perfect intersection of nature, tech, and human institutions. Moving right along to part 2, classifying Earth's wealth. We're breaking down the categories here. Since classification is pretty much a guaranteed topic on your exams, let's make sure we have this locked down. Our first grouping is based on origin. On one side, you've got biotic resources. These come from the biosphere, meaning they have life. We're talking flora, fauna, fisheries, and yep, even us human beings. On the flip side, abiotic resources are all the non-living elements. Think rocks, metals, and land. Next up, we classify them by exhaustibility. Basically, can they run out? Renewable resources, like solar power, wind energy, forests, wildlife, these can all be replenished through physical, chemical, or mechanical processes. Non-renewable resources, though, those occur over mind-bogglingly long geological timescales. Fossil fuels and minerals literally take millions of years to form, and once we burn them or dig them up, that's it, they're depleted forever. All right, let's talk about ownership. This goes from your own backyard all the way out into the open ocean. Individual resources are privately owned, like a farmer's plot of land. Then you have community resources, accessible to everyone in an area, like a village pond or a public park. Zooming out, national resources cover everything within a country's political boundaries, plus the ocean up to 12 nautical miles off the coast. And finally, international resources sit way out in the open ocean beyond 200 nautical miles. No single country can just grab those without a global agreement. Our last classification is based on development status, and you really want to remember the differences here. Potential resources exist, like the massive wind energy potential in Rajasthan, but we just aren't fully utilizing them yet. Developed resources are the ones we've already surveyed and are actively using today. Now, these last two are tricky, so listen up. Stock represents materials with incredible potential, like extracting energy from the hydrogen in water, but we simply lack the technology to unlock it right now. Reserves, on the other hand, are a subset of stock, where we do have the technology, like water stored up in dams, but we're deliberately saving them for future generations. And that brings us perfectly to part 3, sustainability and Agenda 21. It's all about managing resources for the future. We've just listed all these incredible resources, but here's the elephant in the room. What happens when we use them recklessly? Blindly exploiting our environment for a quick buck doesn't happen without massive consequences. It has led straight to huge global ecological crises. I'm talking global warming, ozone depletion, rampant pollution, and severe land degradation. The Club of Rome actually sounded the alarm on this resource depletion way back in 1968. And that warning eventually led the global community to this absolutely crucial concept: sustainable development. Simply put, it means growing our economies today without stealing the resources of tomorrow. It's all about finding that balance. Which leads to a massive landmark moment in 1992. Over 100 heads of state met up in Rio de Janeiro, Brazil, for the first ever International Earth Summit. There, they signed a major declaration called Agenda 21. This was a cooperative global framework aiming to heal the planet, fight poverty, and tackle disease. But honestly, the smartest part of Agenda 21? It recognized that global problems need local solutions. It actually mandated that every single local government should draft its own localized Agenda 21 to fit its specific on-the-ground needs. Moving into part 4, India's major soil types, the literal foundation of our agriculture. Let's zoom in from that global stage directly to the soil right beneath our feet, in India. Before looking at specific soil types, we need to recognize just how diverse India's land is. 43% of the land is made up of plains, which is fantastic for agriculture and industry. Mountains make up 30%, guaranteeing the flow of our rivers and boosting tourism. And the remaining 27%? That's plateau regions, packed with rich reserves of minerals, fossil fuels, and dense forests. This varied landscape is exactly what dictates where our different soils form. It literally takes millions of years to form just a few measly centimeters of soil. The uppermost layer is the topsoil. This is the nutrient-packed zone where all the agricultural magic happens. Below that, you've got the subsoil, which holds sand, silt, and clay. That rests on weathered parent rock, and way down at the base is the solid, unweathered bedrock. The absolute most important soil for India's food security is alluvial soil. It thickly blankets the entire northern plains and the eastern coastal strips. Why there? Because it's continuously deposited by three massive Himalayan river systems, the Indus, the Ganga, and the Brahmaputra. It is insanely fertile, packing the perfect mix of sand, silt, and clay. Plus, it's super rich in humus and lime. Now, for your exams, you absolutely have to remember the difference between the two ages of alluvial soil. Khadar is the new alluvial soil, mostly found down in the lower floodplains. It gets replenished every single year, has super fine particles, and is intensely fertile. Bangar, on the other hand, is the older alluvial soil found higher up on the terraces. It's less fertile and is full of these hard calcareous nodules that locals call kankar. Next up is the very distinct black soil, also known as Regur soil. This stuff was born from ancient volcanic lava, or basalt, spreading across the Deccan Plateau. And let me tell you, it is a cotton farmer's best friend. It's made of extremely fine, clayey material, which gives it a literal superpower, moisture retention. During the scorching hot summers, it develops these deep cracks, which is amazing because it essentially aerates itself. Plus, it's absolutely loaded with nutrients like calcium carbonate, magnesium, and potash. In stark contrast to that, we have laterite soil. The name actually comes from the Latin word later, which means brick. This soil forms in tropical zones where you have high temperatures and incredibly heavy rainfall. Because the rain is just so intense, it washes away the soil's nutrients in a process called leaching. That makes the soil highly acidic and really low in humus. You're mostly going to find this in parts of Maharashtra, Odisha, West Bengal, and the Northeast. Finally, we've got arid soil, which ranges in color from red to brown. Found largely out in the western parts of Rajasthan, this soil has to endure extremely dry climates, blazing temperatures, and super rapid evaporation. That gives it a very sandy texture and a saline nature. Because the moisture evaporates so fast, it severely lacks humus and water, meaning it needs a ton of irrigation to be useful for farming. All right, last section, Part 5, Erosion and Soil Conservation, how we protect our most valuable assets. We've seen just how diverse and vital these soils are, but we've got to face facts. They are under severe threat. Soil erosion is basically the stripping away of the topsoil faster than nature can ever replace it. Now, sometimes this is natural, like heavy rains causing sheet erosion that just washes away the top layer, or running water carving deep gullies into the earth. But human activities, we are the massive accelerators here. Deforestation, overgrazing by giant herds of livestock, and unsustainable farming practices are degrading our land at a scary pace. But we are not helpless. We can totally fight back. Soil conservation is completely within our power. It starts with afforestation, literally just planting more trees so their roots can anchor that topsoil in place. We also need to manage livestock grazing to protect our grasslands. Out on the farms, we can use precise techniques like contour plowing, which means plowing along the natural lines of a hill to physically slow down the water flowing down the slopes. Terrace farming works similarly by cutting wide, flat steps into steep mountainsides to stop erosion in its tracks. In dry, sandy areas, we can plant rows of trees to create shelter belts, acting as windbreaks to stabilize dunes and lock down the soil. As you wrap up your prep for your exams, I want you to remember that these aren't just dry textbook facts to memorize. From understanding the difference between community and national resources to knowing the crazy chemistry of black soil, these are the literal building